Welcome one and all to this third episode of D&D Season 2. And we work on a platformer. And my name is Mike.
And my name is Zoe.
Yay! Alright, so we need to do things. Do you remember what we need to do?
We need to make the input so that the rays so that the input moves them around.
Okay, so, but there was another thing I think. Oh yeah, we had the rays come out wrong. And I fixed that by coming up with the right formula, so we might as well show them. So what we had last time was this. And here's a lovely daddy fix, which I explained to you, so I'll explain it again to them, whoever them is. So, we multiply y, which makes sense, by the iterator divided by the side ray density minus 1, which is exactly the same as what we had before. And then that multiplies the entire size of the player, which is 2 in our case, subtracting 2 paddings, one for the top and one for the bottom. And that makes sense. So we have the correct height, right? But at this point we would still be starting from 0. So that's not good enough because we need padding from the bottom. So we are adding padding from the bottom, like so. So now all of this can go away and we can quickly demonstrate, save please, and we can quickly demonstrate this works. No, wait, you can't really see it from here, but you can from here. Ta-da! Wait, there we go. See, there's a little bit of padding up at the top, a little bit of padding at the bottom, and this ray is right in the middle, and it works with all sorts of things. We've already tested it, so I don't think we need to demonstrate. At any rate, now what we need to do is we need to change what these depend on based on the input. Right? Which direction they're going. So let's do that. Inside update, we have our little movement input, and that's saved as it's stored as a local variable, so we can use it all over the place. Check sides. Here it's checking for right. Now all we need to do is we need to multiply this by mathf.sign
Sign like this?
Nope, the other sign.
So,
yeah.
This kind of sign.
This, yes. Okay, open round, and you need to feed it movement input .x. .x.
Sign.
Close the round.
What does sign do again?
It returns the, well, it's self-explanatory. It returns the sign, so whether it's plus or minus of whatever you send it. So if you're sending it a negative number, it's going to return -1. If you send it 0 or a positive number, it's going to return 1.
Okay.
So one thing that we definitely should do, though, is we should not check the sides if the movement input.x is lower than a certain threshold. Okay, so let's create that threshold. This is already becoming chaotic fairly quickly. Let's see. Well, because we need to categorize it. We'll do it later. Anyway, for the controls, I think they're fairly important. We need to put them at the top here. Create a public float. Actually, why does it need to be public? Not public. There, copy this. Paste it here. And call this one space controller dead zone. Dead zone. Semicolon. Actually, give it a default value of 0.2. Float. Save. Okay. Now we need to check if the movement input is higher than that, to then check the sides and also move and all sorts of things. Yeah, so this one is dealing with movement.x, and this one is doing with movement.x, and this one is 2. Wait, do we need no, wait, Daddy has bad ideas. This is the only one we'll worry about here. So go if mathf.abs. Remember what this does?
Absolute. Well, no, I don't. Again.
Abs returns the positive value
Of everything.
of whatever you feed it. So feed it movement input.x, close the function, is higher or equal to dead zone, whatever we called it, controller dead zone, that's the one. Close the round, open a squiggly, wait, close it now, save. So it's only going to add that velocity if it's large enough. And anyway, the thing should already work, I would believe. So save. Let's test it. So now we should see the rays go right or left. So see the problem, if we don't move, they go right.
Yeah, I see that.
That's weird, actually. It looks to me like the characters slide in a bit. Huh, yeah. The reason why it's sliding now is because when we go below the dead zone, the velocity is kept and just naturally absorbed by the physics engine. Hey, you know what? That doesn't look too bad. Yeah, anyway, so let's try this. Mr. Spider-Man. No, not spiding at all. Okay. So one thing that I'm curious is, yeah, it feels to me like the gravity is being applied excessively now. There.
Wait,
anyway.
though, are you making it fall sideways like that?
Oh. Do you see that?
Yeah.
Do you know why that's happening?
Why?
Well, because the input is being turned to 0, and 0 has a positive sign.
You're right.
So that test needs to happen all the time, but a sign of 0. So we got the problem that 0 is excessively low, or just not particularly intelligent the way we're doing things. So it's not Spider-Man-ing, but it is sliding down fairly slowly because of that bug. Alright, so let's go fix this. The issue is here. See, the movement input gets turned to 0 artificially because there's a side obstacle detected, and then on the next one, because the input is 0, we check the sides like that. So I'm thinking cut this and put it right here. Save. Save. So I've put the test one step after the movement input, which should override that 0. Let's see if that's happening. Yeah.
Yep. No slidey or anything now.
Yeah, but I do get the impression that the acceleration suddenly stops as you're going up. But yeah, I think so. It doesn't look too unnatural, but I don't know. Okay, well, this is working just fine, I guess. I'm not too happy with the double jump. It bothers me a little bit. The delay annoys me. I feel like I need to press it sooner and it doesn't let me. Let's try. Reduce that. Player. Jump delay 0.35. Let's try that. It's hard to make these decisions. Yeah, missed it again. See?
Yeah.
Too much. Let's try 0.25. Ooh, this is quite different. Nope. No, it did. No, it did. It's hard to say. It will behave differently in play mode as well, and we're not really using real time, so we should probably come up with some better solution for that. I don't know what though. Interesting. And if you let go of the controls, you just fly all the way forward as opposed to falling down because the inertia of the ground doesn't apply, right? Yeah, that's not great. Okay, we need to change that. So the issue here is here. right? We're changing the velocity, the x side by the speed, and then we're decelerating. But if we're in the air, we're not decelerating. How do we do this to slow down? I'm not sure. Well, I mean, we could go with the cheap solution for now. Copy this, paste it here, save. So this is gonna force the input at 0 when we're below the dead zone. Oh, hello.
You can't.
Oh, that's above. What an idiot. Okay, hit else. Open. Enter, enter, close. Save. Copy all of this. Paste it here. Put 0F. Save. There we go. And now it should work. Now we'll immediately snap to a stop again. Yeah. See? Now it's... So, I mean, it's not great. I think in the air we shouldn't have full control of our character anyway. On the ground, maybe it also shouldn't be this extremely quick at stopping. So, what do we do, Zoe? How do we make it happen in the air?
What do you mean make it happen in the air?
Well, basically, in the air, I think we should have a completely different system of accelerations, right? Right now, it's the ground movement is fine, in my opinion, except the stopping. That one, I think I preferred it the way it was before. But if we're in the air, we shouldn't be able to control our character quite as well.
Mm-hmm.
Do you agree?
I think so too. Yeah.
Okay. So let's go ahead and make some pseudo inertia in the air. So this I'm going to remove for now. Save. Okay. And when we jump, we need to stop dealing with this. So let's do this. If open round, grounded, yeah, close round, open squiggly, wait, close it now, save. Okay, so let's see what happens if we do this, because I want to see if we manage to jump in the correct direction, because it's, yes, now it completely ignores my input in the air. You can see this, right?
Mm-hmm.
Yeah, so we want to improve that, but it's still better. And if you jump twice, it will jump in the same direction, right? I would like to be able to jump in the opposite direction depending on which side my input is going. Okay.
I think so too. Yeah.
Yeah. So let's see here what the situation is. Right. Okay. So only if we're grounded, though, it's working fairly well. Actually, let me check one more time, because I think the slowdown. Yeah. I quite like this just a little bit of slide, right? It cannot be too much, because otherwise it feels horrible. I personally really dislike the new Super Mario's, because Mario literally slides all over the place. I can't enjoy them at all. So we'll manage that anyway, by changing the physics materials maybe. I don't know, we'll see. Jump delay, I think we tried 25 was better, so let's put it there. Now, there it is, if we're grounded. Put an else if we're not grounded. Open a squiggly, yeah, save. We are going to copy all of this for now, paste it here. And instead of change the RB velocity, we're going to add a force, just like we add in a force in the gravity. So go here, type add force. There, open around. New. Okay, vector 3, movement input speed. Okay, we're gonna have a different air speed for the air. We'll see. Nothing for the Y, so 0F. 0F on the Z, comma, force mode, dot, acceleration, close round, save. Okay, now let's add an air speed. Copy all of this. Paste it here, airspeed. Let's give it a 100 or something. Save. And now here feed it airspeed. Good. Done. Save. Let's see how this looks like. Let's see. Whoa, I clicked it twice.
Oh.
Bad man. I have no idea if it's working. Yeah, yes it is. But it's very, very low. Okay, so we need to...
Are you even double jumping?
No, I'm just single jumping to see how it works. For now, so let's put 300. There we go. Yeah, we can slow down. It's still not enough in my opinion. So let's try leaving it at 500. Not enough. But it is slowing me down. So one issue that we've got is that going forward we can now go faster than our maximum speed. So we're gonna have to fix that, right? Because otherwise it's going to be weird on the ground.
It looks like wind is there.
What do you mean wind is there?
Because it's accelerating when you're falling.
Okay. Yeah, so let's fix one thing at a time. So first this thing with the air velocity, I want more. I want more control. So let's try 750. Yeah. Yeah, I prefer this. Right? It gives me a chance of slowing down. Now obviously for the going forward fast is excessive, right? Hey! Look at that. Ah! You can cover half the screen doing that. And we still don't have a contrastive force when we jump backwards. But that's okay. We'll fix that. Okay. So airspeed was 750, so let's write it here. We may even change it later. And what we need to do is we need to disallow the velocity being higher on the horizontal line. So this would be our possible highest. So let's do that. We're gonna say here if... No, actually, let's not even do that. Let's just clamp the vector. We should be able to do it. So RB velocity equals, copy this, paste it, equals, and now you go... actually, no, this needs to be even after the gravity. Yes, so cut this, put it here, save. And now we're gonna say... let me think. Yeah, well, because the problem is the velocity can be negative or positive. Let's do vector3.clamp and then we'll see. I don't even know if you can clamp a vector3. Yes, you can. Clamp magnitude. Oh, so you can only clamp the magnitude. No, wait. This one do. That's not what we want. Go new vector3. Open a round bracket. Okay, so now we're gonna have to mathf.clamp. Yeah, this will be pretty good actually. .clamp. And copy, paste, .x, comma. And we need to clamp it to a velocity. Oh wait, it can be negative or positive. So copy this, paste it here, go negative, comma, paste, close round, comma, And this one is going to be, copy this, paste it here, put a Y, comma 0. F.
Oops.
Yeah. Wait just
again.
No, I clicked you around. F, close, semi, save.
There.
Okay, so I don't know if this is gonna work, but it basically should clamp us to the maximum possible to the left, maximum possible to the right. It will leave the Y alone, and it will reset the Z on 0. Should do. So now we shouldn't be able to accelerate over a limit. Yeah, thought so. See, now we can't go faster than how fast we walk. Right?
Which is good.
Which is fine, but we can still slow down. There we go, right? I can slow down in the air and then go in the other direction and make all sorts of decisions, right? Ah! Oi!
Oi!
Goodbye.
Bye.
So
What do you do there?
I think what happened is that we fell too fast somehow for the grounded thing. Not sure. Yeah, well, I'm not sure. There will be weaknesses in our system. When you see that little bounce on the ground, that's a weakness. That's dangerous. I can't jump. I've broken myself. The reason why this is because we only have one raycasting on the ground. Right? And when you're in that position, it basically doesn't count.
Should we add more rays then?
Well, I don't know. Wait to see. Yeah, we will. Actually, I want to try this thing of the slowdown. You see, the issue with the slowdown is okay, not this case, but you risk like sliding down when you're trying to make precision movements, right? I'm not sure I like this. It's excessive. It's Mario-like, right? I don't like it. I want to have more control. Yeah, otherwise you're gonna slide down and do all sorts of annoying things. Right? See, I can't get there. Yeah, it's just not good enough. It feels like soap. Anyway, we'll worry about that later. So this is still done, still works. Ooh. Now the one thing I want to do next is do the reversal jump, just like I did here on the ground, right? Where I'm going in a direction and then I turn around and jump immediately. I know it's unrealistic, I don't care. It's a platformer, right? I need to be able to like turn around. Even though this turning around may be a little bit excessive, we'll see. Yeah, we're doing a lot of ad hoc stuff. It's probably not ideal. Anyway, let's carry on. So, jump. There's a jump right here, and it changes the velocity, and it keeps the velocity on the X. We can't do that. We need to, in fact, decide which way to go. So, we're going to take exactly this, copy it, and paste it here, and paste it here. Save. Let's see how this looks like. Yep.
Can I try?
Yeah, go ahead.
Yeah, it works.
Should even be analog.
Wow. No Spidey. Well,
what are you trying to do?
I'm trying to see what happened here. It falls pretty. It slows up to the air and falls. That's because of the cart, right?
Yeah. Okay. Good. Bonk.
Dying.
Yeah, so the slidiness is
Not very good.
No, not great. But at this point, it's not so much about us calling this dead zone, but like a slow down zone. So let's rename that one. Control R twice. And call it slow down zone. Slow down zone. Okay, save. And give it a value of 0.1. Let's see how that feels like. Save again. This may essentially completely negate everything we're doing. No, it's still slidey. Yeah, it changes nothing. And the reason why that is because we go directly from a number to a 0. If you can hear my clicking of the stick, right? I'm going to 1 and then 0, or -1 and then 0. So that just doesn't help. It's the amount of time that's necessary to slow down that is causing us a bit of grief. Yeah, I think we should develop some kind of intelligent method to decelerate deliberately. But how? So this is for grounded, etc. This is just higher or lower than slowdown zone. Let's undo what we did. That zone was still good. There we go. Because it's representative of what it is that this does. But the problem is there's no else, and then the rigid body is just left to itself to slow itself down. And I think the thing that's slowing it down is the gravity that's pushing it down all the time anyway. So, well, we can check what our velocity is and do something to contrast it. Let's try that. So here, go else, open a squiggly. Yeah, and here you go, copy this, paste it here, hit shift tab on this one, save. Now instead of testing movement input, test RB velocity, rb.velocity. Yeah, so the velocity of x in either direction is higher than 0, f. Not higher or equals, but just higher, save. We're going to gently apply a force going backward. So copy this, paste it here, go right here, and I don't know this. We're gonna have to make a decision. I just realized something, that this is stupid. Anyway, leave it there. It's not current gravity, it's something else, some kind of like stopping speed or something. So let's call it that. There, airspeed. Copy this, paste it, and go stop speed. Yeah, this one, let's make it a lot lower. Save, copy. This may make it almost instantaneous, which may not be good. Paste it here, and here you go, times mathf dot sign. Yeah, open of rb.velocity.x dot x. So we're getting the sign of the velocity horizontally, close the bracket. Okay, and we're gonna take the opposite. Save. Okay, there we go. Let's see how this looks like. Yeah, we have a slowdown, but it's a bit, I don't know, man, feels extremely similar. So let's increase this to a ridiculous amount. Let's see what happens. Whoa, hello. I'm not doing anything. Yeah, it's probably moving in some small directions, and it's putting so much. Wait a second. I'm an idiot. Oh, that's a good. It exposed the thing. So stopping speed, sure, but it also depends on the magnitude of the velocity, not just this. So remove this. Save. And actually, this should be normalized, I think, to get us the direction. Heck, I don't know. No, just leave it as it is for now. So we're keeping the magnitude of that velocity. We'll find out now. Goodbye. I'm not moving, people. there is no inertia. Oh.
Oh. How do you stop it?
Pure luck, I think. Yeah. It's going forward forever. Okay.
Even in the air?
No, I don't think so. The air doesn't have this stuff happening to it. So times stop speed times, oh, I'm an idiot, negative of RB velocity. Save. We need to go in the opposite direction than the one we're going. So let's see. Oh man, if only I had gone to school to study this stuff. Okay, this is definitely better.
Yeah, definitely. That doesn't slide around.
It slides a bit.
Just a little bit, not too excessive.
Right, but see, I can get like to the edge if I want to. Okay, here I overshot a bit, and plus we're missing those ground rays, but there, that's not too bad. There you go, it's not too bad. It's not too bad. Boop. Okay, perfect. So, what do you want to do next? Fix the ground rays, that's one thing we need to do. Another thing we should do is make Mario jump. Meaning you can hold the button a little bit longer and you jump a little bit higher.
I think we should fix the ground rays first.
Alright, sounds good. Well, that's fairly easy to do because we already have one system here to deal with the side rays. It's going to be exactly the same for the ground rays. That's really it. So we're going to need origins. So copy this. Paste it here.
And padding. Don't forget about padding.
Yeah, call it ground. Ground. Save.
Grund. Wait.
Save. Copy this. Paste it here. Now this one is going to be half the size of this.
And we need to change those two.
Yeah, one moment. Save. Put square brackets here. Square brackets here.
Oops.
Put an S. Put another S. And put a ground here. Save. Okay. So this is gonna take a bit, but we'll fix it all. Okay, so first of all, let's go to start setup side rays. Rename this to setup rays. Hit Ctrl R twice. No, backspace. Say enter. Okay, so now we got setup rays. Now it will set up all of the rays. We don't have a density for the ground, which we need. Copy this. Paste it here. And call this one ground. Grounds. Save. Let's leave it on 5 as well for now. Okie dokie. So here are our side rays. Now we need to do the ground rays. So copy all of this. Paste it here. And here you want to go ground. Let's copy this. Paste. Copy this. Paste. Copy this. Paste. Copy this. My bad. Copy this. Paste. 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 Save. Save.
There's one more. There's one more.
Sure. Paste. Save. Save. Alright. So vector 3 right. Okay, so here we're going to have a different problem. And this formula is not going to be perfect for these guys because our pivot on the X, where is it? On the Y it's at the bottom, so that gives us an advantage. But on the X it's where?
In the center?
Yeah. So we need to move left first and then add the padding. By how much do we need to move left?
As much as the length.
Length of what?
The padding.
No. You need to first so remember that the rays are populated left to right, okay? Now the problem is if you populate them now, they go from the center further. So you exit the body even on the right. Now we need to compensate that by pushing to the left. Okay? By how much? How far to the left should you go?
half the
what?
the body.
That's right. Half the size of the body. So we can do this. Well, we'll do that at the end. So this one, first of all, type right here. Okay. And you also want to do another one, which is plus vector3.left left. Yeah, times, and it's called player size. Copy this, paste, .x, and you said half, so divided by 2f. Okay, save. So we're adding the padding from the left. We're going all the way to the left. All right, and now there's the usual calculation. So to the right, yeah, ground ray density, yeah, that's
There's
good.
side ray padding there. We need the
We need the ground ray padding, which is
and then we need to fix all those errors.
here. Copy this, paste it here, and then here. Okay, and size X. Save. Okay, so this should work, I think. So we've got the origins done. Awesome. Now we need to worry about these. And for these, you need to do just like the sides. Side obstacle direction, that doesn't matter to us at all. Let's see. Side rays. Okay. So copy this loop, paste it here, and close it here. Save. Now here you want ground ray density. Okay, now S, add an S, square bracket, I, close square bracket, is new ray transformed opposition vector3.up, player size, transferred opposition plus something, but not this. We need the ray origins. Okay, so we're gonna say, and it also, yeah, though this part is pretty important. I don't remember if our ray origins do account for that, but I don't think so. So let's go take a look. Yeah, so they go to the left, but they're not adding the height. So we're going to do it right here. Half of the height. So copy all of this and paste it here. Okay, so I don't like that there is so much stuff all in a row. So what I'm going to do is I'm going to find the first sum. I'm going to indent this, then find the first sum, indent this, find the second sum, indent it, and the last one, indent it, save. So I have a fairly good visibility of what it is that we are doing here, right? Now this is necessary to put them in the center of the body. Perfect. Okay, so now we got them in the center of the body, so we can take the side. Ground.
Side, ground. Phew.
Or gropund. Gropund.
Rotund.
Save. It's like a new version of rotund. Copy.
What is rotund?
Means fat person. Oh, I'm sorry, you're not supposed to say that. Well, I don't care. It's a fat person.
Oh.
I'm rotund.
Oh.
Yeah. More than rotund, I think.
Oh.
I think the word slob applies. Anyway, so blah, blah, blah. Here, paste it here. I, save. Vector3.down is still correct. Okay, so ground rays, S, I. Ground hits, I. Yep. And ground rays I origin. Yep. Ground rays I direction. Save. So if any of these is hitting the ground, we are officially grounded. We can stop the jump delay and we can reset the air jumps. Okay, that's good. S bracket I and S bracket I. Save. Okay, now this is wrong. Because we definitely know that we're grounded if at least one of them is hitting the ground. That's fine. But if not all of them are hitting the ground, we've got an issue. It's not going to be considered grounded at all. Rather, what am I saying? Right now what's happening is that basically if the first ray is grounded, cool, but the second one isn't for whatever reason, then grounder goes back to false. We can't do that. What we're going to have to do is change this a bit. Okay, so we're going to create an int here and call it ground ray count equals 0. Or gerund ground ray count equals 0. Semicolon. Save. Okay, now copy this, paste it here, plus plus. Semicolon. Save.
Oops.
Wow. Save. Alright. Now cut this.
Oops.
Here you're gonna say if ground ray count higher than 0, close round, open squiggly, enter, enter. Jesus Christ, Zoe, will you start focusing, please? Open a squiggly, enter, enter, close it. Paste. Alright, so if we have at least one hit, we're grounded. Else, if we have no hits, after we've done all of the loop, now we know, cut, that we can safely be not grounded. There we go. Save. Alright, so this will partially work, it won't work perfectly. And the reason why it won't work perfectly, okay, there are little rays, you can see them. There's all 5, they're already padded correctly, so we got our formula right. Whoop, whoop. That there's a little slidey bit, right? But what I'm trying to achieve, so the problem here is exactly as I thought. It's our collider is causing this. Okay?
That bump.
Well, yeah, the fact that we fall. Because we are basically playing with a real circle, rather capsule here. We could be cheap and just replace the collider with a box collider, but I'm not a big fan of that. I would much prefer to basically handle all collision completely virtually, so that our little collision sphere-y thingy doesn't literally do anything. So,
Can't we just go to physics and do all that?
Well, no. The point is to turn off physics completely. Meaning we use the rigid body, but not the collider at all. We may still use the collider for other reasons later. Turn it into a trigger collider. As a matter of fact, I think we should do that. But watch, if we now go to the player collider and we go is trigger, goodbye. Right? The problem is that our gravity is pushing us down, but nothing's pushing us back up when we're hitting the ground, because the only thing that was doing that at this time was our little collider. Okay, so what we're going to do now is we are going to change it so we don't need the collider to stop anymore. In order to do that, we're going to need to use our rays. We're going to have to say if grounded. No, wait a second. Undo. No, what are you doing? Breaking everything. Save. So if our ground ray count, we know we're on the ground. So what we need to do is we need to stop the falling, but we can't because we are falling after this. Right here. So this should only apply if not falling. Therefore, if not grounded. So cut this, paste it here. Save. And this is not going to be perfect, I don't think, but it's already going to do some things. Oop, or nothing. Okay, that surprises me a little bit because, okay, so that says that we're not grounded, fine. But at some point we should get that we are grounded, no? Wait. Here. Change this to 0f. Save. Try now.
Bye-bye.
Okay, still not working. That surprises me because we start not grounded, and I understand that. So it should push us down, and I understand that. But then at some point we should get here. But we don't. Why? Go debug.break. Open, close round, semicolon, save. Yeah, check sides. Eh? Wait a second. Where's check grounded? If not, just jumped.
Check grounded.
Yeah, but if not, just jumped. So do we get just jumped? Okay, it's worked. No, it's worked. See, we got the debug.break. And now for some reason...
It's falling through that.
It's falling, even though it's consistently grounded. So, save. Where is it? Where did I get it wrong? This, but that's fine. That should be correct. Because the velocity should be 0, but it isn't. Oh! Idiot. Right here. Copy this. Paste it here. And here you're gonna say copy this. Paste it here. Save. Actually cut all of this. Put it here. So that's where we're canceling that bloody thing. Okay. And now land. There we go.
It landed.
So
it's flying though.
I know. And you're gonna get these imprecisions. The reason being is because we're doing something too simple. What we need to do is, and by the way, we now have a problem with hitting things above ourselves, right? I mean, it's something. It's not working perfectly, but it's all right. So what we need to do now is we need to basically force the player.
I saw it slide when it fell down.
Huh?
Go back on the wall and get down
It's
again.
It's definitely sliding a bit more than I like. What did you see?
When you got stuck in the wall and you fell, it slided quite a lot. Slid. Without jumping though.
Here?
No, when you fell off the wall. When you move yourself off the wall.
Like this?
When you were in the wall, and you moved yourself out of it. See how much it slid?
I don't see a particular difference between that and this. Yeah.
You're right.
Yeah, they're identical. Anyway, so it's not perfect, but it's doing a few things, and that's nice. So I'm a little surprised that the side here isn't stopping us. That's weirding me out, because I thought that we did put a... that's interesting. If I hold left, yeah. So there's something. Oh no, I think it's the ground. Yeah, it's the ground.
The ground ray is hitting the side ray.
Yeah, it's fine. Irrelevant. They ignore each other. Okay, so the deal here is that our rays are hitting at different times depending on when we land, which is not ideal. And what we need to do is we need to force a certain position. And we do know the position, actually, because it is half of, no, not half of the body, rather, it's 0. We need to put it we need to make it so that the distance between the point we hit with the ray and ourselves is 0. So that's fairly easy. Right here. No, where am I? So that's all fine. Let's hit Control ML because my brain is starting to explode. Check grounded here. When we are grounded, one thing that we are going to do is we're going to change the position of the transform depending on our point. Right? So here you're going to say transform dot position.
Oops.
equals new vector 3 open round transform.position.x. So we're not changing that, comma, and this one instead needs to change, and it needs to change depending on where we hit the ground. So we need to store that, don't we? I think so. So here you're gonna say float, yeah, and go ground point. Ground point y, add a letter y, equals 0f, 0f, semicolon, save, save, okay, copy this, paste, equals, ground hits 1, copy, paste, dot, transform dot position dot y, semicolon, save, copy this, put it here, comma, and copy this, add a t because I'm stupid, paste, close round, semicolon, put a z, save. Okay, see how this goes. Pop.
Into the floor.
Pop. Yeah, the question is it happening exactly in the same position all the time?
Yeah, it looks like it.
Yes, it does. And the reason why this is happening is because your dad is a bit silly. So what I gave you, like, look, now when we jump from underneath, boop, it pushes us up.
But we don't want that. We want it to bash our head.
Well, I know. We'll worry about that later. One thing at a time, Flower. Because we are destroying the entire normal system in which Unity does this, right? This is a big deal, right? So we need to rebuild everything so that it works the way we like it. Okay, so the reason why this is happening, can you figure it out? It's actually fairly obvious. Where am I grounded now? What am I touching?
You're touching the center of the floor.
The center of the block. That's right. That's why this is occurring. Because I told it to go to the center of the floor. And that's a stupid idea. What I should have told it is instead, ground hits should be dot point. I'm fairly sure. So try dot point. Yep. Dot y. Save.
Oh.
Or select all. Save.
Whoops.
And now, much better.
Now it's actually touching the floor.
Mm-hmm. See, it already feels like we actually have a correct collider now. That sliding is still a bit eh. So
Well,
you saw there's quite a lot that, you know, still needs a bit of work, but that's okay. One thing that I would definitely change soon is the way we are raycasting from the center. It's too far. So that's why this is happening. We're going to raycast from much further down. Let's do it right now. That's easy. All we need to do is go to the origins, right? And instead of taking the origins from the center, we're going to take them from the bottom. And to do that, this one over here needs to go. So hit backspace here, save. Now, the issue is the length of the ray is way too long. You actually want it to be super short. So do 0.2, save. Now this won't work because it's stored on the object. So we need to say right here 0.2, save. Okay. Now the rays should only shoot from the bottom. Whee!
Oi.
Okay, there they are.
Huh?
Yeah, I'm confused because they did turn green. So I'm not sure. Interesting. So we start falling later for
Sorry
some
about
reason.
that.
Oh, of course, because the rays are too far inside. They are now basically inside the collision. So then it doesn't count as hitting anymore. So we're going to undo this. And here, instead of doing this, we're going to say vector 2 up. And let's add the padding here. Okay, so copy ground ray padding, which is kind of the opposite, but anyway, paste it here. As a matter of fact, we're going to change this to side ray padding. Side, yeah, save. And now for the length, we're going to have to say it's going to be side ray padding plus whatever it is we already have here. So type side ray padding plus side ray padding. There it is. Yeah. Space plus. Save. Okay. And now this fella. Yay! Winning. Now the cool thing about this is that, see? Oh, hello.
Oh, bye.
That went poorly.
The cool thing about this is like fail.
No, I know why. I know why this is happening. The physics engine isn't recognizing this fast enough, so it's not robust enough. All right. The issue is this is now risky. We're gonna fix that in a different way. So let's remove this guy here, and let's restore the situation we had before, which was copy all of this, paste it here, put a Y, save. And now the ray length needs to go back to what it was. Huh? Ah, we've already undone it. Lol. Okay, 1, 2. We'll fix it in another way. That save. When we're making platforms that you can enter, you know that Mario has platforms that you can go from underneath up, right? And then land on top of them.
Yeah, I think so.
Yeah, well, that's happening here, right? We'll fix this later. I'm not worried about it. Now, what I'm a bit worried about is the fact that here my rays aren't detecting, dude, you're hitting the side. Fall. That's not happening, right?
Mm-hmm.
Like it's not stopping our velocity when we hit a wall. So we need to go and find out why. So, check sides. Side obstacle direction. Brilliant. So that's giving us this information. And now, where is side obstacle direction? There it is. Okay, so that's definitely not ideal. What we're doing is we're actually changing the input if we have a side obstacle direction. And we are not going to do that. We're going to do it a bit differently. Right here we're going to do it. This is both for the ground and the air. So copy this. Actually, no. Wait just a second. We're going to do it here at the end. So cut all of this. Save. I'm a bit worried about this, but fine. Paste it here, save. So if side obstacle direction is higher than 0, oh dear, that's
What?
still from back then. It only accounts for right and not the left. Okay, wait. Excuse me. Okay, so this is wrong. We need copy this, paste here, and this needs to be an int. So you need another mathf dot round to int. Open round and close it. Save. Okay, so now at least the side obstacle direction is correct. Right. So here, if the side obstacle direction, we're gonna take the absolute. So here you go, mathf.abs abs, open around, close the round, save. So if we do have a different direction than that, we're going to change the RB velocity x to 0. Okay, so we're going to say, I think we could probably use this. So cut this, put it here, and else, open squiggly, paste, and this one's fine because the velocity, the side obstacle direction is actually. I just realized your dad is doing stupid calculations. Remove this, and instead of this, check if it's 0. That's way cheaper. Save, and here say 0f, and here leave that. Save. Okay. Now let's see if our side is going to work now. It should. Yeah, we're going to stop after this. Oh boy. Hello.
We can't even move.
Yeah, we can't. And I think I know why. Because I'm stupid. I did it the other way around. Copy this. Oops. Paste it here. Put a 0f here. Save. Alright. There we go. Let's see if we can move now. Yay! There we go. See that? So it's not perfect again for the same reason, because we simply changed the velocity to 0, and also because we're still in the air, we're applying a force. So we're actually sliding into it gently. That's something we definitely need to look into. See how complicated it is to do this? We could. That's why I asked you. So guys, you don't know this, but I asked Zoe before we did the lesson. I went, do you want to make a physics-based platformer? And for the life of me, I couldn't remember one, or I couldn't think of one. Then I said Limbo, and I showed her some videos of Limbo, and I told her, see, the movements are a lot more sluggish and slow and that sort of stuff, right? It's very slidey. And then I gave her the example of the new Super Mario, etc. And then she said, no, I want one game. I want a game that's precise in the movement. And I said, that's quite a bit more difficult, but okay. So now we're doing it this way, but it's coming along. Look at that, look at that. Ah! Yes. But it's working perfectly in terms of landing on things. So that I'm quite happy of. Later we're probably gonna add the, we're gonna add a way to, why do I get stuck like I'm old? I don't remember what I wanted to say. That's embarrassing. Sorry. Anyway, okay. Well, we're done for today. Thanks very much for watching. Bye.
Thank you. Bye.